Welcome to this predicted paper from onmaths. This paper represents the best guess for the upcoming exams. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing. Enjoy! For us to create the largest number, we need to pick the biggest digits for the start of the number. So the biggest digit is 7, then 6, then 4, then 3. But the question says it wants the largest even number, so we need to just swap the last two around to make sure that it is even. So our answer is 7,634. So with this question, we need to first of all count how many sides this polygon has. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's 10 sides. And we just need to know that a 10-sided shape is a decagon. Now we are expected to know all of the names of shapes between 3 and 10 sides, so if you don't know them already, just sit down and learn them. If I split this shape into two sets of 6 blocks, when we're asked to shade in 3/6, for each one of those, or each set of blocks, I'm going to shade in 3 of the 6. So that's 3 for the first set, and this is 3 for the second set. And that's our answer. Now you might notice that 3/6 is the same as a half, because we can divide on 1 by 3, and so all I need to do is shade in a half. Or you might convert 3/6 into 6/12, and there's 12 squares altogether, so it's 6 of the 12 squares. There's lots of ways of doing this question. Multiples are just a numbers times table, so to write the multiples of 11, we're just going to do 1 times 11, 2 times 11, 3 times 11, 4 times 11, and 5 times 11. Now we're not going to do any more because it says it just wants the first 5, so I'm just going to write those down in a list with commas, separating them. So we need to first of all understand what a cube number is. So a cube number is the answer to when you get 3 integers or whole numbers and we multiply them by themselves 3 times. So 1 times 1 times 1 is 1, 2 times 2 times 2 is 8, 3 times 3 times 3 is 27, 4 times 4 times 4 is 64, and 5 times 5 times 5 is 125. So 1, 8, 27, 64, 125 are all cube numbers, and it goes on forever. And this question's asked us to find all the odd, or an odd, cube number that is smaller than 100. So it has to be odd, so that gets rid of the 8 and the 64, and it has to be smaller than 100, so that gets rid of the 125. So I can either write down 1 would be a fine answer, or 27. I'm going to go for 1. The first thing we need to work out is the fraction that Sarah will receive. Well, if Jane receives 9/10, then that just leaves how much of the numerator to match the denominator. So 9 plus 1 is 10, so it leaves 1/10 left for Sarah to have. And the reason that works is that the total amount needs to add up to 1, and 9/10 plus 1/10 is 10/10, which is just 1. So next we need to find out what 1/10 of 60 is. So we know that we divide by the bottom and times by the top. So 60 divided by 10 is 6, and then 6 times 1 is just still 6. So our answer will be £6. So 55% is the same as 55/100. And what I can do is I can divide top one of the fraction by 5. And so that is going to equal 11/20. Now in total there are 20 squares here because there's 5 across and 4 down. 5 times 4 is 20. And if there's 20 squares and we're looking to shade in 11 20ths, it's just going to be 11 squares. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I'm going to start just by writing down the number. And we're asked to round this to 3 significant figures. And basically what that means is starting from the left-hand side, it's 3 numbers that we want. So 1, 2, 3. And we're going to do our line after that third number. And you start counting the first non-zero digit. So the first digit there was 2, so we started counting. Now all the numbers to the left, or sorry, to the right, so these numbers here, will all turn to 0. But before that happens, we look at this number. Now this number, if it's 5 or more, it moves this number up by 1. If it's less than 5, that number stays the same. Now it is 5 or more, because it is 5. So it's not going to be 207, it's going to be 208. Now, a common mistake is that students write down 208. No. All the numbers to the right of that line turn to 0. So it would be 0, 0, 0. So it would be 20,000 or 208,000 exactly. So for shop A, they're selling the rulers in lots of 3. And so we just need to get our 60 and divide it by 3 to figure out how many lots of 3 we have. So we've got 20. So if one bundle of rulers costs £1.50, then 20 times £1.50 would be £30. So in total it would cost £30 at shop A. We're going to do the same for shop B. Their bundles are 5 rulers, so we're going to do 60 divided by 5, which is 12. So we're going to buy 12 bundles at £2 each, and that will be £24. So the cheapest price is at shop B at £24. So we're going to start off by working out what 100% of 120 is. Well, that's obviously just going to be 120. And we're trying to get to 6%. So we always start off by working out 10%. It's always normally useful. And we just divide that 120 by 10, so we get 12. And we try to get 6%, so it'd be nice if I knew 5%. And 5% is nice and easy because we just halve that 10%. So that'd be 6. And if we got the 1% as well, we can get to the 6%. So to find out what 1% is, we just divide the 10% by 10 and get 1.2. So to get the 6%, we're going to add the 5% and the 1%. So we're going to add the 6 and the 1.2. And so we just do 6 plus 1.2, which is just going to be 7.2. And that's our answer. To multiply fractions, all you need to do is multiply the tops. 3 times 7 is 21. And multiply the bottoms. 4 times 11 is 44. We see whether we can simplify this, but actually there's no number that goes into 21 and 44. So it's 21 over 44 is our answer. To be able to add or subtract fractions, we must make the denominators the same. So what we do is we write out the 5 and 7 times tables. So 5, 10, 15, 20, 25, 30, 35. And you keep going through each times table until you get to a number that's the same in both. You can see it's 35 here. So we're going to times top and bottom by something to make the denominator 35. So for this first one, it's going to be 7. So we're going to times top and bottom by 7. For the second one, it's going to be 5. So 2 times 7 is 14. And then the bottom will be 35, the denominator. And then 2 times 5 is 10, and the denominator will be 35. Then when we have that, we take away the numerators. So 14 take away 10 is 4. And that just leaves 4 over 35. So we can see whether we can cancel it, and we can't. So the answer is just 4 over 35. So what we need to do is find out where the graph is at its highest. And so it's highest here. And so if we go down from there, we find out what year it is. Well, these years seem to be going up in 1. So that's 1950, 1951, 1952. So the answer would be 1952. So we start off by working out what 100% of 240 is. Well, that's obviously going to be 240. And a nice easy one to start off with is 10%. And we're trying to get to 21%, so 10% is always a good one to start with. So we divide by 10, which would be 24. And because we try to get to 21%, we'll need to find out what 1% is. And 1%, we just divide the 10% by 10 again, so it would be 2.4. And then we need to find out what 20% is. And 20%, we just double the 10%, so it would be 48. And so 21% is this plus this, because 1 plus 20 is 21. So we add these together, so 2.4 plus 48. Probably don't need to do this formally. Probably do this in our heads. So 50.4, but it says to increase 240 by that amount. So we need to get 240, we need to add the 50.4. Probably, again, don't need to show the working out for this, we can do this in our heads, but it's a bit easier to see what we're doing. So the answer would be 290.4. So you do need to know the parts of a circle. So the full distance around the circle is called the circumference. If you've got a little bit of it, it's an arc. If you've got a line across it, that would be a chord. And the part that's kind of trapped in there is called a segment. Then if you've got a line across the circle going through the centre, that's a diameter. If you've got a line just going to the centre, if I can draw it properly, then that's called a radius. If you've got a line that touches the circle just on one point, like that, that's a tangent. But in this case, we have a sector. So with a stem and leaf diagram, the numbers in the middle often represent tens. They could be units. So we look at the key first of all, and we see that 3 line 9 means 93. So the numbers in the middle are going to represent 10. So this is a 90. Now we're looking for English, so this will be 92. So our first number will be 92. Then this will be 10 tens and a 4. So it would be 104. 11 tens and 1. So 111, and then 11 tens and 2. So to find the median, we go cross out the biggest and smallest until we're left with 1 or 2 in the middle. Here we're left with 2. So what we're going to do is we're just going to add the 104 to the 111, and we're just going to divide that by 2. So when we do that, we get 107.5 or 0.5. So our answer is 107.5. Let's rewrite this expression, but with a time sign in, so v times w squared. Now w squared just means times by itself, so we can rewrite that as v times w times w. Okay, so we know v is minus 10, so minus 10. And we know w is minus 4, so it's times minus 4 times minus 4. Okay, so when you multiply, it doesn't matter which order we do it. So what I'm going to do is I'm just going to do these ones first, and I'm going to ignore that times minus 4 at the end. So minus 10 times minus 4, that's a minus times a minus, which is a positive, 10 times 4, which is 40, times minus 4. Now we're going to do 40 times minus 4, so it's a positive times a negative, so that's going to be a negative. And 40 times 4, well, 4 times 4 is 16, so 40 times 4 is 160. So it's going to be minus 160. So the first thing we're going to do is write this as a ratio between the fractions. So we're going to have green to black. Now it says that a quarter of the counters are black, and therefore the remaining counters will be green. So if a quarter are black, that leaves 3/4 to be green. And what we can do here is on both sides of the ratio, what I'm going to do is just times it by 4. So I'm just going to times 4 both sides. So 3 divided by 4 times 4, because over 4 just means divided by 4. So 3 divided by 4 times by 4 just gets rid of the fraction. And 1 divided by 4 times 4 is just going to be 1. Now, this might surprise some people because they will probably think it's a ratio of 4 to 1, but we can show here that it's a ratio of 3 to 1. For this question, it's really useful to label angles that you know on the diagram, even if you can't go straight to the answer. So I know that if I extend this line here, but let's do a bit of a better job of that. So if I extend this line here, the north line, then I can work out what this angle is, because it's going to be the same as this angle here. And the reason is it's Z angles, which are alternate angles. So I know that this angle is 35 degrees because of alternate angles. The question asks to find the bearing of C from B. So we're at B and we're finding the angle that C makes from north going clockwise. Well, it's going to be this angle here we're looking for. And if we look, we already know what this side is, which is 180 degrees because it's a straight line. We've got the 35 degrees there, and we've got the 21 degrees. So it's going to be 180 plus 21 plus 35. It doesn't matter which order we add them, which will equal 236 degrees. So I'm going to write the fact and the question kind of one on top of the other, so we can see what's going on. So we're going to write the question underneath. Now you'll notice that the question is very similar to the fact. And in fact, we can see that all we've done here is we've times that by 100. And all we've done here is we've times it by 10. So what have we got to do with our answer? Well, we've got to times it by 100 and times it by 10. In other words, we've got to times it by 1,000. And so we're going to times this by 1,000 and we'll get 11,187 as our answer. To work out the circumference, we need to first of all work out what the diameter of this is. And to do that, we just draw a line across the circle and we can see the diameter is twice as big as the radius. So the diameter is going to be the radius times 2, which is 28. Formula for the circumference of a circle is just pi times the diameter, which will be pi times 28. Now to write this in terms of pi, which the question asked for, we just put the number first and then pi. So it will be 28 pi. To find the surface area of the cuboid, I'm just going to label the faces and do them individually. So we've got A, which is 24 by 13. So we're going to do 24 times 13, which is 312. Next we're going to do B, which is this one at the top, and it's 24 across and 8 is the length. So 24 times 8, which is 192. And finally C on this side here, which is going to be 13 times 8, which is 104. Now notice that the faces all have the exact same face on the opposite side. So this one at the back is also A, this one at the side is also C, and the one at the bottom is also B. So what I'm going to do is add up all the areas of the squares and double it. So to work out the surface area, we're going to do 2 times and then 312 plus 192 plus 104, and that will give me 1,216 centimeters cubed squared, because it's an area. To find the largest weight this package could have been before it was rounded, let's do a quick number line, and we're going to just do it between the 24 and what it would round to next. Well, it's 10 nearest kilogram, so the next thing it would round to is 25. the cutoff point for rounding is here. And that's going to be halfway between 24 and 25, which is 24.5. And that is actually going to be our answer. Now, some of you who are astute might realise that 24.5 would round to 25, but theoretically the biggest it can be is going to be 24.49 recurring. Let's just draw that a bit better, 24.49 recurring. And that is actually the same as 24.5. In your exam, however, you can write 24.49 recurring and you would get full marks, but for brevity, I would definitely recommend writing 24.5. So for this question, what we need to do is factorise 4t plus 6. Now, factorise means put it into brackets. So if I try, what I can do is I can actually put a 1 on the outside here. So 1 times 4t plus 6 is 4t plus 6, but the question clearly states that it is higher than 1. So we need to find another number that's higher than 1 to factorise this with. So if we look at 4t and 6, well, they're both in the 2 times table. So I can put a 2 on the outside here. 2 times 2t is 4t, and 2 times 3 is 6. So what we can do is we can just check that out with smiles and rainbows. Put all my times down there to remind me to times it. So 2 times 2t is 4t, 2 times 3 is 6. So that works because that is the same as this in the question. So we know that 2 times 2t plus 3 works. In fact, it's the only one that works with it being an integer. So we therefore know that the known side, because it says it's a known number, is 2. And the other side will be 2t plus 3. And then when you multiply them together, you get the area of 4t plus 6. So our answer, because it says the length is the known number, so that's the length, then we're finding the width, which is this one here. So it's 2t plus 3. So when we say y is directly proportional to x, what we mean is whenever x doubles, y will double. Whenever x halves, y will halve. Now, we've got this proportionality sign here, and to make that an equals, all we need to do is introduce a k constant to the right-hand side. So it's y equals something times x. Now, to find out what that something is, to find out what that constant is, what we're going to do is feed in the value of y and the value of x that we have. So we're going to feed those in. So y is 55.3 and x is 7. So it would be 7k. And we're just going to put our lines in and solve this. So it's going to be divide by 7 both sides. And 55.3 divided by 7 is 7.9. And that's what k is. So we're going to rewrite this equation here, this formula here, y equals 7.9x. And that is actually our answer. So it's really important, first of all, we make clear about how we convert things. So if I've got a unit in kilometers and I want to convert it into meters, then we know we just times it by 1,000. So 2 kilometers is 2,000 meters. But if I have something in kilometers squared and I want to convert it into meters squared, I actually times it by 1,000 squared, which is 1,000 times 1,000. Okay, so I'm actually times it by not 1,000, but 1,000 squared. So that's another 3 zeros. You can see here that that's 1,000,000. So we times it by 1,000,000. So 13 kilometers squared is going to be the 13, and then it's going to be times by 1,000,000. So 1, 2, 3, 1, 2, 3. So it's going to be 13 million. Now, it says here the farmer must pay 1 pence tax for every metre squared. So this is going to be 13 million metres squared. And so that's going to cost him, or her, 13 million pence. But the answer is going to be in pounds. So we just need to get rid of 2 of the zeros at the end. So it's going to be 13, 1, 2, 3, 4. So it's going to be £130,000. So if 2 people liked action but not comedy films, and in total 11 liked action films, therefore there's going to be 9 who also liked comedy, because these two have to add up to 11. Now if there's 9 who liked action and comedy, and 16 who liked comedy in total, if we do 16 take away the 9, that leaves 7. So 7 only liked comedy. It says there's 23 people altogether, so what we're going to do is take away the people who liked action, the people who liked both, and the people who liked comedy. Take all those away from 23, and we're left with 5. So the answers are going to be 9, 7, and 5. If I start by drawing a number line, and we're going to put the 110 in the middle. Now I'm going to label the next one down and the next one up. It says to the nearest 10, so the next one down would be 100, and the next one up would be 120. Now we're interested in the cutoff, and the cutoff point is between the two numbers. Okay, so that's the cutoff point. If it goes above that cutoff point, it would have rounded to the next number up. So if the number was here, it would round to 120. If the number is on the cutoff point, which we can see is going to be 115, then we know it would round up. So we need to find the biggest number in this part here. So this part here, and it includes this line actually, so it includes this line. So all the numbers that would have rounded to 110 would have been 105, 106, 107, 108, 109, 110, 111, 112, 113, 114, which would be here. But if it was 115, it would have rounded to 120. So 114 is the biggest number it could have been before rounding to 120, and we know it didn't round to 120 because in the question it says it's 110 to the nearest 10. So our answer is 114. So angles on a point add up to 360, and we are given the values of the angles but in terms of r. So we know that r plus 9r plus 20 will equal 360. So we've got an equation here we can solve. So first of all, let's add the r's together, and so that will be 10r plus 20 equals 360. Then we're going to subtract the 20 from both sides. So we have 10r equals 340, and then we're going to divide by 10 both sides. So we have r equals 34. So our answer is 34. There are 2 rules for things to be in direct proportion. The first rule is you must have a straight line, which we do on this question. The second rule is it must go through the origin. So we're looking for a line like this or like that, somewhere in that region there. Now this red line does not go through the origin, so A and B cannot be in direct proportion. So I'm going to start just by writing out the equation, and I can put my lines in. Okay, we're asked to make x the subject, so we're going to first of all add 10 to both sides. In fact, I'm just going to move all this over a little bit so I've got a bit more space. Okay, so we're left with m plus 10 on the left hand side, and we've got 1/7 x on the right hand side. Now to get rid of the 1/7, what I can do is just times both sides by 7. So 7 brackets m plus 10 equals x. So x therefore would equal 7 brackets m plus 10, but it says to expand your answer fully, so we're just going to expand the brackets. 7m plus 70. To find the pressure, we need the area and the force. And we're given the force in the question, and so all we need to do is find out what the area is, which will be the 7 times the 9, which will be 63 centimeters squared. and the force is given to us in the question. So what we can do is write down the pressure formula, which says that pressure equals the force divided by the area. Force is given to us as 2268. The area we've calculated is 63. Divide the two and you get 36. So it's going to be 36 newtons per centimetre squared. So to find the area of a rectangle, we do length times the width. So here, to find the area, we will do the 10 times the whole of the 10t plus 4. And to show that we're doing the whole of it, we put it in brackets. So a different way of writing that is 10 brackets 10t plus 4. And whichever method you use to expand brackets, feel free to do it here. I'm going to just do the grid method, but whatever method you prefer. Actually, I don't need the, I've done too many here. Let's get rid of that. So we've got 10 times 10t plus 4. So and we're timesing them. So 10 times 10t, 10 times 10 is 100. So it'd be 100t. 10 times 4 is 40. So our answer will be 100t plus 40. So we're going to first of all work out where 9 is on the y-axis. Well, we've got 8 here and 10 here, so 9 will be halfway in between. And what we're going to do now is just draw a line across at 9, and then wait until it hits the line. And then we're going to draw a line down, and you can see here that x is 1. So our answer is that x equals 1. So we're asked to work out the average speed. So we've got to first of all remember the triangle. So average speed is total distance over total time. And we're told to find the average speed before stopping. So stopping is shown with a horizontal line on a distance time graph. So it's up to this point here. So the average speed will be the total distance, which would be 20, over the total time. So 9:30 to 10 will be 30 minutes, but since our units will be kilometers per hour, we need that in hours, which will be a half. And 20 divided by a half is going to be 40. So our answer is going to be 40 kilometers per hour. I'm going to write this out just a bit bigger so we can see what's going on. And there are loads of different methods for expanding brackets. I'm going to use smile and rainbows. So smile there, rainbow there, and I always put a little notch here to remind me to times it. So we're going to do 4 times 8, which is 32. And x times x, which is x squared. Then we're going to do 4 times 3, which is 12, and x is just there. So when we expand that, we get 32x squared plus 12x. To find solutions for quadratics on a graph, all you need to do is find out where the graph meets the x-axis. Okay, so the coordinates this graph meets the x-axis are here and here, and that would be minus 0.8 and minus and 0.2, and they're also called roots. So with each of these pools, try and imagine it being filled. So pool A, first of all, we've got water coming into it, and it's actually going to go quite quickly initially, and then it will hit a point at the end where actually it will go really quite slowly because it's a wider pool. So we would imagine that the graph for pool A would actually go quite quickly at the start, and then at the end it would go much slower. And that doesn't really describe, the red graph doesn't really describe that at all. So for pool B, we start off actually quite quickly because it's quite thin, and then we have a wider bit here, so it will go slower here, and then we go quickly again. So we need a graph that starts off quite quickly, then goes slowly, and then goes quickly. And the steeper the graph on our depth time graph, the faster it's filling up. And that red line doesn't really describe that either. Pool C, however, we can see it goes slowly at the start, and then because it's thin it will go quicker, so nice quickly, and then it will go slowly again. Well, that is a perfect description of the graph that we're given. So the graph we're given is definitely going to be for pool C. So we can write this as a fraction, so it would be 2.84 times 10 to the power of 11 over 4 times 10 to the power of minus 2. What we can do is split this up into two fractions, so 2.84 over 4 times 10 to the power 11 over 10 to the power of 2, or minus 2. Okay, so we're going to start by doing 2.84 divided by 4. So we're going to just do the bus stop method, so 4 on the outside, and we've got 2.84 on the inside. 4's into 2 don't go, so carry the 2 across. 4's into 28 go 7, and 4's into 4 go 1. So it's going to be 0.71 times, and then the rules of indices say that if you divide two powers of the same base, they're both 10, then you just take away the power. So it's 11 take away minus 2. Now the two minuses, the two takeaways, actually convert to a plus, so it would be 11 plus 2, which would be 13, so it would be 10 to the power of 13. Now we've got a bit of a problem here because standard form must have a number between 1 and 10, and not including 10, at this position here, and this is obviously less than 1, so we need to convert this into standard form. So what we can do is just write the number out again. So I'm going to write this as an actual number, so it's 10 to the power of 13, so it'd be 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13. Fill in the zeros. So it'd be 7, 1 and all those zeros. And then I'm going to put it back into standard form. Now the decimal point will need to be here to make it 7.1. So it'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's going to be 7.1 times 10 to the power of 12. Now, with a bit of practice, you don't need to write out the whole number. You'll be able to just know that if you convert that into 7.1, then you just need to take away 1 from the power. But if you're not sure, and it's not an unreasonable number like 10 to the power of 105, then it's just worth sometimes just writing out the actual number and being 100% sure that you've got it the right way around. What I'm going to start off by doing is rearranging this equation so that it kind of matches this one. So I'm just going to write it down. And we want the n to be minus 2. So what I'm going to do is I'm just going to put my rearranging lines in, and we're just going to add 10 to both sides. Now, we've already got this line drawn for us on this graph. And so all we need to do is draw this line. So we've got y equals 10x squared plus 8x minus 2 drawn for us. We just need to draw this line, which is y equals 10, and see where they cross over to find the solutions. So y equals 10 will be all the way up at the top. Let's just make sure I get it nice. There we are. I need to move that up a little bit. There we are. And let's read off the values that that gives us. So it comes down here, and it comes down here. So the values it comes down to are minus 1.6 and 0.8. And those are our solutions. So the way this formula works is we have m, which is the final amount. The 2000 here is our initial amount. The decimal in here is our multiplier, and the power here is the amount of years. So the way multipliers work is they are the percentage divided by 100. So if we go the other way and times it by 100 to make it back into a percentage, it will be 102.9%. Now it says what is the interest rate of the bank? Well, the interest rate is always going to be 100%. Well, this 102.9% is 100% plus the interest rate, which will equal the 102.9%. So the interest rate is going to be the 2.9%. You always start off with 100%. So if I put £5 into my bank, I've got 100% of that £5, and then the interest rate is on top of that 100%. So our answer here will be 2.9%. To find the resultant vector, we just get the two vectors and we add the tops and add the bottoms. And it's a plus minus 13, so it's 9 take away 13. When we do that, we get 13 at the top and minus 4 at the bottom. So this question is a simultaneous equations question. And so we're going to have to write down some equations. So it says 2 apples and 3 pears cost £3.80. So 2 apples, I'm going to call it A for the price of an apple, plus 3 pears, so 3p, cost £3.80. Now I'm going to do this as 380 just because it's easier to work with integers rather than decimals. And it says 3 apples, so 3a, plus 8 pears costs £7.80. or 780 pence. Okay, so the first thing I do is try and get these numbers the same. So 3 and 8, they both go into 24, so I need to make them both 24. And what some people do is they just label this A and this B. And so what we're going to do here is we're going to multiply everything in equation A by 8, so that this becomes 24. So it's going to become 8A. And so we're going to times the 2A by 8, which will be 16a plus 24p, and 380 times 8 is 3040. And we're going to do the same with b, but this time we're going to times it by 3, so we're going to have 3b. And we're just going through everything here and we're timesing it by 3. So 9a plus 24p, which is good, that's what we wanted. And 780 times 3 is 2,340. So now we've got both of these the same coefficient. What we can do is we can eliminate going downwards. Now, if they are the same, the s in same is the s in subtract. If they were different signs, so if these weren't both positive, if one of them was negative, different, the d in different is the d in add. So here they are the same, so we are going to subtract. And we're going to subtract going downwards. So we're going to start off by doing, and I can just do a little line here to show what we're doing. So we're subtracting going downwards, and we're going to do 16a take away 9a, which will be 7a. 24p take away 24p, which is nothing, which is why we did that, is to eliminate them. And then 3040 take away 2340 will be 700. Then I can put my lines in, and all I need to do now is just divide both sides by 7, and I get A equals 100. So we know that apples cost 100, or £1. We need to work out what pears cost. So I just need to pick one of the equations. I'm just going to pick this top one here, and I'm going to write out. But instead of A, we know that A is £1 or 100 pence. So plus 3p equals 380. So that's going to be 200 plus 3p is 380. And then again, I'm just going to draw my lines down. And we're going to subtract 200 from both sides. So it's going to be 3p equals 180. And then we're going to just divide by 3 both sides. And we've got p equals 60. So a pear costs 60. Now we can check this by using the other equation there. So 3 times 100 is 300, plus 8 lots of 60 is going to be, what's that, 480? So it's going to be 780. So we know that we've got it right. Y is inversely proportional to x means that y is proportional to 1 over x. And I'm going to change that for an equal sign by timesing the right hand side by k, and k represents our constant. And we're told that when x is 5, y is 10.8. So I'm going to fill those in. I'm going to substitute those in to be able to find out what k is going to be. So it'll be k over 5. And we're going to be solving this. Let's get my lines in. And solve it, I just times by the bottom of the fraction. So times both sides by 5. And we're going to end up with 50.4 is equal to k. So k is 50.4. I'm going to rewrite this equation here, but we know what k is. It's 50.4. We're asked to find the value of x when y is 9. So we've got 9 equals 50.4 over x. And whenever in this situation here where we've got the unknown at the bottom of a fraction and we've got it equal to a number, what you can do here is actually just swap these around. Effectively, we're timesing both sides by x and dividing both sides by 9. But it does really help us out here because it just says that x is equal to 50.4 over 9. We can just do that on the calculator and it gives us 5.6. First thing we notice is that there is a square here. So we can work out what this length is going to be. It's also going to be 40 centimeters. And whenever we're working out the area of a shaded area, we're normally working out the area of two shapes and subtracting one from the other. And this question's really no different. So we're going to start off working out the area of the square. And all we need to do now for that is 40 times 40, which will be 1,600 centimeters squared. I normally only put units in our answer. The next thing we're going to do is work out the area of the circle, but to do that we need to work out what the diameter of the circle is, and if you notice that the diameter of the circle is just 40 degrees. It's the same as the width of the square, or height of the square. So if the diameter is 40 degrees, the radius would be 20 degrees. So for the circle, for the area of the circle, we're going to do pi times the radius, which is 20 squared, and 20 squared would be 400, so this will be 400 pi. This question's asking us to leave it in terms of pi, so we're going to do that. Now next we're going to work out the all of the corners, so that includes these three here and this one. So I'll say, like, I don't know, 4 corners. Just try and explain to the person marking my exam what I'm doing. And to do that, we're just going to do the square, take away the circle. So 1,600 take away 400 pi. Now we can't actually do anything more than that. That is our answer. So it's just, we just leave it at that. And to work out just the shaded bit, which is this bit here, they are 4 equal amounts that we've got for these corners. So just one corner, which is the shaded bit, will be the 4 corners divided by 4. Now we've got a kind of fraction here. We can divide all of the terms by 4. So that will leave 1 at the bottom, 100 pi here, and this will be 1,600 divided by 4 is 400. So we're just cancelling the fraction, and actually we leave it as 400 minus 100 pi, and that indeed is our answer. You can't simplify that any further. So we're asked to express TQ in terms of P and Q. Well, we've got another Q here, because all of these are congruent parallelograms, and we have a P there. So if we're starting at T and getting to Q, we can go along this path here and down this path here. So we're going backwards down Q, in fact backwards down 2 lots of Q, and then the correct way down P. So it's either minus 2Q plus P or P minus 2Q. So here we're given a right angle triangle, and the question involves two lengths and angles, so we know we could be using trigonometry. So let's start by labelling our sides. The one opposite the right angle is the hypotenuse, the one opposite the marked angle is the opposite, and the one between the right angle and the marked angle is the adjacent. Now notice the hypotenuse doesn't have a number or a letter next to it, so let's get rid of that. Next thing we do is draw our trigonometry triangles. So we've got SO, Ca, Toa. Now we've crossed out the H, so we're not going to be interested in the SO or the Ca. So it's going to be Toa. Toa is short for tan the angle equals opposite over adjacent. The angle is 60, so it's tan 60 equals x over 1. And so now here we're looking for the exact value of x. So if I times both sides here, let's just get our solving lines in here, and times both sides by 1, or just get rid of the fraction, we end up with x equals tan 60. Now you need to know off by heart what tan 60 is, and we can work it out just briefly by drawing a right angle triangle. Sorry, not a right angle triangle, an equilateral triangle. So that is going to be 60 by 60 by 60. And we're going to put all the lengths around the outside as 2. And what I'm going to do is I'm going to cut it down the middle. And I'm just going to cut it into half. And so the length at the bottom will be 1. And using Pythagoras, we've got to work out the length here. It's going to be 2 squared, which is 4, take away 1 squared, which is 1, will be 3, and then square root it would be root 3. So we know that's going to be root 3. So looking at labelling the sides here, just pick a colour to make sure it's nice. So we've got the hypotenuse here, we've got the adjacent here, and then the root 3 will be the opposite. And so we're looking for tan 60. So tan, as we know, is the opposite over adjacent. And so tan 60 is going to be the opposite, which is root 3, over the adjacent, which is 1 in our diagram there. So tan 60 is equivalent, it's the same as root 3 over 1, or just root 3. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing.